Lesson is over solving systems of linear inequalities. And to solve systems of linear inequalities, the method for doing this involves graphing. And so you're really looking at a whole region of area where the solutions are, instead of just one particular point or one particular intersection. And there's really only two steps to this. The first step is you need to graph all the inequalities and then lightly shade the solutions of each inequality. So remember, that's where we're going to create the half plane. We're going to make a line and we're going to shade one side of the line. Remember, as you make that line, if you have a less than or greater than symbol, that is going to be a dashed line representing that anything that lands on that line is not an answer. If you have less than or equal to or greater than or equal to, then anything that lands in that line could be an answer. And so you do have to keep track of that. The region that is shaded by all the inequalities is the solution to the linear system. So you have to really look at that light shading that you've done and see, okay, what parts are shaded by all of them. So let's look at a sample problem. There could be just two inequalities, kind of like we've done before, or you could have a situation like this. This is a problem where there's some constraints on it. And so what constraints are is it just limits it to particular areas. And so as you glance at this, x is greater than or equal to 0. That's a common one, and really what it means is any of your x values that you're going to use have to be greater than or equal to 0. So x is greater than or equal to 0. Remember, x I think horizontal, and it's the opposite of what I think. So x equals 0 is a vertical line at 0. It could be equal to that, so I want to make sure that I have it as a solid line. And now I got to look to shade. I want to shade the x's that are greater than or equal to 0. All the solutions are greater than 0. Those are to the right here. And so this whole area over here would be shaded. Now as I look at the next one, x is less than or equal to 8. So I want to make that line as well. And so again, I think, okay, x, I think horizontal is the opposite of what I think. It's a vertical line at 8. So I come over here to 8. And I make a solid vertical line. Now, all the solutions are less than or equal to 8, and so when I go to shade, now I'm shading everything to the left, over here. Now you look at it, it can get kind of sloppy here, but look, the area that I'm concerned about is the area that is shaded by both of them. And so right now, the area that is shaded by both of them is going to be in between the lines here. And so I want to get rid of all this stuff over here, because that wasn't shaded by the first one. And I want to get rid of all this stuff over here because that wasn't shaded by the second one. So right now I'm just concerned about this middle region right here. I go to my third line now to graph. Y is greater than or equal to 0. As I go to graph that, again it is or equal to, so it's going to be a solid line. Its y is greater than or equal to 0, so it's going to be a horizontal line at 0. This would mean that all the y values that you have to be greater than 0, so they have to be up here. And so again, just to kind of shade that in here, and I'll use a different color to kind of show where it's shading. I'm shading everything up here, everything above that horizontal line I had. Now remember, what I'm interested in though are the areas that work for all of them. Okay, this area out here, that doesn't work for all of them. This area down here, that doesn't work for all of them. And this area over here, that doesn't work for all of them. But anything in this column here, this region here, right now that's a solution there because that works for all of them. I go to my last one. My last one is right here. Y is less than 1/2 x plus 4. It's in slope-intercept form. I know that it crosses the y-axis at 4. I know that the slope is 1/2 because that's the number by the x. And so I go up 1, right 2. I also know it goes through that point right there. Notice that it is less than, so it's going to be a dashed line. So I want to make sure I use my dashed line as I go through there. And then remember, for shading on these lines here, it's a little bit more difficult than the others. We have to kind of look at a particular ordered pair here. And I always like to look at 0, 0 if it works. So let's do that. Let's plug in 0, 0. If I plug in 0, 0, 0 is less than 1/2 times 0 plus 4. Well, 1/2 times 0 is just 0. 0 plus 4 is 4, so I have 0 is less than 4. You have to analyze that to see if it's true or false. It is true. That means that the solutions to this problem are all on this side of it. So these are all solutions down here. Now, remember, what I'm ultimately looking for is the place where all 4 of the inequalities works. And so if you remember, I couldn't have anything over here because the x has to be less than 8. I couldn't have anything here because it had to be greater than this. Couldn't have anything down here, and I couldn't have anything here. So my solution set, my solution to this problem is right where it is shaded, right in this area. So remember, all the solutions are here in the yellow, and so when you do your shading, look for the part that is shaded by all of the lines that you're dealing with in the system there. Wherever that is, those are all the solutions. So any ordered pair that is in this yellow area is a solution. Any ordered pair that is on this solid line, or this solid line is a solution. Remember, if there is an ordered pair that is on the dashed line, that is not a solution. I'm going to end you with a knock-knock joke, maybe something that's even been around longer than bacon. Not better than bacon, but has been around a long time, and those are knock-knock jokes. And so here we go. Knock-knock. Who's there? Dishes. Dishes who? Dishes me. Can I come in? Have a great night.